The diagram shows a rhombus ABCD. The points B and D have coordinates 2, 10 and 6, 2 respectively, and A lies on the x-axis. The midpoint of BD is M. Find by calculation the coordinates of each of MA and C. So for this question, probably the best idea is to start with M, because probably that's the simplest. So the coordinates of M can be written as, because it's a midpoint, so we can write M as 2 plus 6 out of 2 and 10 plus 2 out of 2, and that would be so M would be 2 plus 6 is 8 out of 2, that is 4, and 12 out of 2 is 6. So the coordinates of M are 4, 6. Okay, so M, we will write here, M is 4, 6. Okay, so the next thing is we have to find the coordinates of A. Now we know that for A, the x coordinate maybe says x1 and the y coordinate will be 0. So A is x1, 0, and to find that, what we do is AB equals AD. Therefore the distance AB, using the distance formula, so what we do is the square root of AB, so 2 minus x1 whole square plus 10 square equals, you will have 6 minus x1 whole square plus 2 minus zeros, that's 2 square. So we can write this as squaring both sides, so we would get 2 minus x1 whole square plus 100 equals 6 minus x1 whole square plus 4. So we get 4 plus x1 square minus 4x1 plus 100 equals 36 plus x1 square minus 12 x1 plus 4. So you see the x1 squares get cancelled out and we're left with minus 4x1 plus 12x1, so bringing the x1 to the left side, so we get 8x1 equals 36 plus 4 is 40 minus 104, 100 plus 4, so that would equal, so you can write 8x1 is minus 464 and x1 is minus 8. So therefore the coordinates of A would be minus 8, 0. So A is minus 8, 0. So that's done. So now we have to find the coordinates of C. So to find the coordinates of C, we have to do a little bit of more work, because C, first of all, we can make an assumption here that it is x2, y2. So you have to find both x2, y2. They don't lie on any axis, so that and we have no way to make one of them 0. So what we can start with is, you see, we know in a rhombus the diagonals are perpendicular, so we can just join AC and it passes through the midpoint M, and what happens is we can find the gradient of BD, and the gradient of AC would be perpendicular to the gradient of BD, so that will help us form an equation. Okay, so gradient of BD would be y2 minus y1. So we do 2 minus 10 out of 6 minus 2, and that is minus 8 out of 4, and that is minus 2. So the gradient of BD is minus 2. So gradient of AC would be half, because AC is perpendicular to BD, and product of gradients is minus 1. So then what we do is gradient of AC we know is half, so we actually can can work out the gradient in terms of the coordinates of A and C. So we can write x2 minus minus 8 divided by y2 minus 0 equals half, or we can write x2 plus 8 divided by y2 is half, and therefore 2x2 plus 16 is y2. No, what did I do? Sorry, I got it all wrong. Because the gradient is, we're doing the gradient, isn't it? See, I went wrong here. So the gradient is y2 minus y1, isn't it? The gradient is y2 minus y1 out of x2 minus x1. So instead of doing that, I did it the other way around. So y2 minus y1 would be, so y2 minus 0 out of x2 minus minus 8, so x2 plus 8 is half. So then I get 2y2 equals x2 plus 8. So I can say x2 equals 2y2 minus 8. So we will keep this this equation expressing x2 in terms of y2. So I can write now that x2 equals 2y2 minus 8. So then what do we do? Okay, we've done this much, but there's another thing we haven't yet used, is that the AB equals BC equals CD equals DA. You know, the all sides of a rhombus are equal. So we haven't used that property yet. So let's see if we can make use of that. So what would be the sides of the rhombus? Now that we know 3 points, we can work out what the side is. So the sides would be, if we say AB, the easiest, because one point is one coordinate, I should say, 0. So AC, the distance, would be minus 8 minus 2 whole square plus 0 minus 10 whole square. So that would give me 100 plus 100, and that would give me square root of 200. So that's the distance. So we can now say that, we can work out that BC should be 200, square root of 200, or CD should be square root of 200 as well. So we do that. We say that BC equals square root of 200, and that equals square root of, we can say 2 minus x2 whole square plus 10 minus y2 whole square. So squaring both sides, we can say 200 equals, we'll square remove the brackets as well, so 4 plus x2 square minus 4x2 plus 100 plus, but before that we can do something, instead of x2 we can put in x2 is 2y2 minus 8. So we can write 2 minus 2y2 plus 8 square plus 10 minus y2 square. So that would equal, so you can write 200 equals, that is 10 minus 2y2 whole square plus 10 minus y2 whole square, and that equals 100 plus 4y2 square minus 2 times 2, 4 times 10, 40 y2 plus again 100, so that's 200, okay, plus y2 square minus 2 times 10 is 20 y2. So you see now what happens is 200, 100, 100, they're gone. So what we have is, we have y2 square, 5y2 square. Therefore, we say 5y2 square and minus 40 minus 20, that's minus 60. Not 40, sorry. 4y2. So that is, yeah, sorry, we did this, didn't we? 5 we have already written. I'm getting confused. So 5 minus 4 plus y2 square, okay, so that's 5y2 square, it's already done, and minus 60, y2 equals 0. So now if you can simplify this to say y2 square minus 5 times 12 is 60, y2 equals 0. So therefore, if you take y2 outside the bracket, you say y2 minus 12 equals 0. Now y2 cannot be equal to 0 as we see, so y2 is not equal to 0. Therefore, we can say y2 minus 12 equals 0, and that would give us, therefore, y2 equals 12. So once we know y2 equals 12, see, we can put it that here. So y2 equals 12, and then therefore x2 would be 2 times 12, that's 24, minus 8, and that equals 16. So the coordinates of the point C are x2, that's 16, and y2, that's 12. So 16 and 12, so that's all done.